We'll be looking at carboxylic acids and their derivatives in this chapter. A carboxylic acid have an OH group bonded to the carbonyl carbon atom. Oops. So it looks like this. Okay, so we have a carbonyl. We have the OH group bonded to the carbon. So really right here, when we have this, it makes it into a carboxylic acid. In the derivatives, the OH group is replaced by the other groups. So for an ester, the OH is going to be replaced with an OR group. So it'll look like, oops. Okay, so here's where we would draw the OH, but the ester is going to replace that, and we're going to get an OR group there. For amides, the OH group is replaced with a primary, secondary amine. So instead of the OR group, we'll have the amine is going to attach there, and we will have the amide. And we'll look at acid anhydrides. They're formed when two carboxyl acids are joined together. Because all of these have a carbonyl carbon atom connected to either an oxygen or nitrogen, they are all polar. This causes them to have similar properties like high boiling points compared to alkanes, and carboxylic acids and amides have a hydrogen that can have hydrogen bonding between molecules. So esters don't have that, but the carboxylic acid and the amides do have hydrogen bonding. Because all of these have a carbonyl group attached to an electronegative atom, they are going to undergo a substitution reaction. They're called carbonyl group substitution reactions. So just to give you an example, okay, so here we have the carboxylic acid, and it's going to react with a group, okay, depending on what reaction we're talking about or what we're looking at here. Whoops. And it's going to substitute. So the Z is going to take the place of the OH. So then we get this. Okay, so we're going to look at the different, and then we'll have HOH. We're going to look at the different reactions that take place with that. The portion that doesn't change during the reaction is called the acyl. So that portion is right here. Okay, so the OH is going to come off. The Z group or whatever group is going to attach there, but the acyl does not change. In biochemistry, carbonyl group substitutions are called acyl transfer reactions, and they play a very important role in metabolism. Carboxylic acids are weak acids. They will surrender the hydrogen of the carboxyl group to a base to establish an acid-base equilibria in an aqueous solution. So when that happens, when it does give up the hydrogen, it forms a carboxylate ion, and we're going to come back to this. We'll talk more about it. Let me write this out. Carboxylate ion. So we'll talk more about these here in just a little bit. But that's what happens because they are weak acids. they will establish that equilibrium. And like alcohols, carboxylic acids are able to hydrogen bond to themselves. Acids with R groups that are up to 9 straight chain carbon atoms that are volatile, and they have unpleasant odors. And then with R groups that are up to 4 carbon atoms are water soluble. And anything greater than 9 carbons are waxy, odorless solids. In naming carboxylic acids, we are going to replace the E from the alkane with an OIC ending. And just to give you an example here. So here we have CH3, CH2, C, OH, O. Okay, so here's our carboxylic acid. So we have 3 carbons, right? And we know if I have 3 carbon chain, it's propane. But it says we are going to, so propane, it says we're going to remove the E and add OIC to it. So we're going to take off the E and put OIC. So propanoic acid is the name of this carboxylic acid. Now, another example. We have this molecule. Okay, so we always start numbering at the carbonyl carbon. So that has the highest priority. So we're going to start numbering right here. So of 1, 2, 3, 4. And so we have 4 carbons. So we know that's butane. And we have a methyl group off of the 3rd carbon. So with butane, we'll start with that, butane. Okay, we know for the carboxylic acid, we're going to remove the E and add OIC. Okay. And then put acid, but we have to also add the methyl group that's on the 3rd carbon. So we're going to name that how we usually do. So say 3-methyl butanoic acid. Common names are used for the most part with carboxylic acids. They were some of the first organic compounds to be isolated and purified. So just some examples: formic acid, lactic acid, acetic acid. They are known by their by their common names, not by their IUPAC names. So in the common system, the carbon atoms attached to the carboxyl group are identified by Greek letters rather than numbers. So alpha, beta, gamma, and so on. So just to give you an example of that. So here we have CH3, CH, and H2. Oops. Keep writing that wrong. COOH. Okay. So we have here, let me write this, the first carbon that's attached to the carbonyl atom is going to be alpha and then beta. Okay, so we would name this, so it's 3 carbon, so it's propane, and so we would name it propanoic. Spelling that wrong. There we go, propanoic. And since the amine is on the alpha carbon, it's called alpha aminopropanoic.